A technology that feels brand new, but has actually been changing the world under the radar for decades. It's called additive manufacturing. Now, you've probably heard of it as 3D printing, but believe me, it is so much more than little plastic trinkets on a desktop. So, what can this stuff really do? Well, for starters, take a look at this. General Electric is literally printing metal fuel nozzles for its jet engines. These things have incredibly complex cooling channels inside them that you just couldn't make any other way. The result? A huge leap in fuel efficiency.
And in the medical field, it gets even more amazing. At the University of Michigan, doctors were faced with an infant whose airway had collapsed. So they 3D printed a custom splint that fit perfectly around the airway, and it literally saved the child's life.
But it's not all serious life or death stuff. You know the James Bond movie Skyfall? They needed to blow up a classic Aston Martin DB5 for a scene. Of course, they weren't going to destroy a priceless original. So what did they do? They just printed one. A perfect full-scale replica, just to blow it to pieces. Okay, so when you see all this cool stuff, it really begs the question. The very first patents for this technology were filed way back in the 1980s. So if it's been around for over 30 years, why does it feel like it's suddenly popping up everywhere right now? Well, the answer is kind of a perfect storm. For one, a bunch of the key foundational patents have expired, which has opened the floodgates for new companies and new ideas. At the same time, the price of the components you need, things like lasers and motors, has just plummeted. And finally, the software has gotten so good that it's actually easy to use. Okay, so let's get into the big idea here. To really wrap your head around additive manufacturing, you have to understand this fundamental shift from carving something away to building something up. At its core, the process is pretty straightforward. You start with a digital blueprint, a 3D file on a computer. Then a machine reads that file and builds the object from the ground up, adding one super thin layer of material on top of another. And that is the essential difference. For basically all of human history, manufacturing has been subtractive. Think about a sculptor with a block of marble. You start with a big chunk of stuff and you cut, drill, and carve away everything you don't want. Additive is the complete opposite. It's a bottom-up process. You start with absolutely nothing and you add material layer by layer only where you need it. So how does this bottom-up idea actually work in the real world? Well, there are dozens of different methods, but most of what's used in industry today falls into one of three main buckets. First up, you've got extrusion, which is what most people think of. It's basically a really precise robotic hot glue gun, squeezing out melted plastic one line at a time. Then there's photopolymerization, which is kind of like magic. You have a vat of liquid resin and the laser draws a pattern on the surface, instantly hardening it into a solid. Finally, you've got powder bed fusion. This is how you print with metal. A super high power laser zaps a fine layer of metal powder, melting and fusing it together layer by tiny layer. Okay, so if this technology is so incredible, you might be wondering, why aren't our cars, our phones, our coffee cups all 3D printed? And, well, it comes down to a few very real-world limitations. When you need to make millions of something, additive manufacturing is still, for the most part, way too slow. The surface finish might not be as smooth as you'd get from something like injection molding. And maybe most importantly, the cost for each individual part can be way higher. These are some pretty big hurdles. But, and this is a huge but, despite all those drawbacks, additive manufacturing has one economic superpower. And this one thing just changes the entire game. And here it is. The superpower is this: complexity is free. What does that even mean? Well, think about it. Because the machine is just following a digital map, it takes about the same amount of time and the same amount of material to print a simple solid cube as it does to print a crazy, intricate, hollow lattice structure of the exact same size. And this is the economic light bulb moment. Look at this table. With traditional manufacturing, the cost line goes up and up the more complex a part gets. Every new curve, every new hole needs a new tool, a new mold, a new process. But with additive manufacturing, that cost line is flat. A simple part costs the same as a mind-bendingly complex part. Customization and complexity don't add to the price tag. And this one single fact, that complexity is free, is what's pushing manufacturing into a whole new frontier. It's unlocking designs, products, and even business models that were just physically and economically impossible before now. Now, to put this all in perspective, you have to see this number. Even though the industry is growing like crazy, over 25% a year, the entire additive world is still worth less than 1/10 of 1% of the whole global manufacturing pie. The room for growth here is just staggering. You know, the Harvard Business Review put it perfectly. They said that 3D printing today is basically where the internet was back in 1995. We are in the dial-up modem AOL free trial CD phase of a technology that is going to fundamentally reshape our world in ways we can't even begin to imagine yet. And really, that's the thought I want to leave you with. As this technology keeps getting faster and cheaper and better, what are we going to create? What becomes possible when the physical limits of manufacturing just melt away and the only thing holding us back is our own imagination?